Next up is feet. And thankfully, we're going to keep Mr. Squeegee's feet very simple. The model just has two pieces per foot, the heel and the toe. And we're going to take the easy way out for this rig and just have one bone for each. But even so, there are some things that we need to think about. The first is translation and rotation axes. The translation and rotation axes of bones are determined by the bone's orientation in edit mode. I touched on this briefly before, but I'm going to go a bit more in-depth into it now. Let's take a look at this armature I've prepared for us. We can see the rest position of the bones by entering edit mode on the armature. I've enabled axis display so that we can see the axes of the bones. And we can see that the y-axis of this bone is pointing off at an angle. Now, if we go into pose mode and play with this bone's y-translation, we see that the bone moves along that local axis of the bone. Even if we rotate the bone in pose mode, that original edit mode orientation is still what determines the translation axes. Moreover, if we give the y-translation a value of, say, 3, and then change the bone's orientation in edit mode, then in pose mode, its position changes. This is because the y-translation value is now operating on the new y-axis, and is going in this direction instead of this direction like it was before. This applies for all of the translation axes, not just the y-translation axis. And it also applies to the rotation axes. If we switch the bone to Euler rotation, and play with its y-rotation axis, we see that it rotates around the bone's edit mode y-axis as well. These oriented axes, with their custom zeroed out positions, are called the local space of the bone. You may have noticed me using that term before, and it is in contrast to something called world space, or sometimes also called global space. World space is the overall space of the scene that everything exists in. If we have a bone floating in the scene somewhere, its world space translation might be something like x equals 2 and y equals 3. That is the absolute translation coordinates of the bone in the scene. On the other hand, if its rest position in edit mode was off here somewhere, oriented at an angle, then the local space translation of the bone might be x equals 2, y equals 1. One way to think of this is to say that the world space is the absolute coordinates of a bone in the scene, whereas local space is the relative coordinates of a bone compared to its resting pose. But bones are not the only things that can have local spaces. They're just the only thing whose local space we can set directly. By default, an object's local space corresponds exactly to world space. But that can be changed if, for example, you give it a parent. In fact, we exploited that in the bouncy ball rig. Remember that when the parent was rotated, the translation axes of the ball changed with it. We were indirectly changing the local space of the ball via a parent. And that happens with bones as well. If we rotate the parent of this bone, then its local space rotates too. So the local space of both objects and bones is affected by their parents, but only the local space of bones can be directly set by us. Whew, that might be a lot to take in, and I apologize if that's the case. Spaces are an important concept in computer graphics and rigging, but they can also be kind of mind-bending. So for now, I'll just leave it at this, and we'll revisit it later. But one last thing. It is important to realize that the coordinates we see here in the end panel, and that the animator will be animating with, always represent the local space transforms of the object or bone. In other words, animators are always animating in local space. And that's why we care about this with the foot. We want to place the foot bones so that their local translation and rotation axes make sense for the animator. If we put the foot bone at an angle, then there wouldn't be a simple single axis for up and down. Also, there wouldn't be a simple single axis for pivoting the foot around its heel. But it's helpful for the animator to have those simple, well-aligned axes, because it makes it simpler for them to, for example, tweak just the height of the foot, or manage the interpolation of the height of the foot. And these are important things for the animator to be able to do. So for our foot rig, we need two bones, the main foot bone and the toe. And the toe will be the child of the foot. And since we want them to have their axes nicely aligned, let's make them horizontally straight. To keep things simple, we're going to assume that the foot bone will be the direct target of the IK leg. So that means that it will need to be positioned where the leg is going to connect to it, which is at the ankle. And that's just a bit higher than the toe. We also want to consider which axis is the up axis for the foot. In Blender, the z-axis is considered the de facto up axis, since that's what world space uses. Let's turn on axis visualization so that we can see if that's what we have or not. Uh-oh. Looks like we have some adjustments to make. Fortunately, Blender lets us roll bones in edit mode. Select the bone, and press Ctrl R to roll the bone in edit mode. You can also change a bone's roll in the end panel here. By positioning the endpoints of bones and setting the roll, you have complete, full freedom to place the bones however you want. Now, in pose mode, we also want to consider axis locking and rotation modes. Since the toe is just the floppy end of a squeegee, we really only need it to rotate on one axis. That means that we should first switch it to Euler, and lock all of its axes except the x-axis, which is what we want it to rotate on. Toes are also typically attached to their foot, so let's lock the toe's translation axes too, so that it doesn't separate from the foot. Now, the foot itself we can pretty much leave alone. It needs to be able to translate, so no locking there, and it is potentially going to be rotating on all rotation axes, so quaternions make sense for it. And there we go, a super duper stupidly simple foot rig. And yet somehow I still managed to fit in a confusing topic. Woohoo!